students, this is a new series on previous year questions which are very important for IIt JEE preparation and especially for 2021.
So the first question is on the screen. The order of differential equation whose general solution is given by y is equal to c1 plus c2 cos x plus c3 minus c4 e raised to power x plus c5. So to find out the order of the differential equation, we have to find out the differential form of this general solution. So let us first convert it into the differential equation form. Okay. So first differentiate it. We will get dy by dx is equal to, this is constant and this is the function. And we know that cos x is equal to minus sin x. And e raised to power x is equal to e raised to power x. So this is the obtained equation after single differentiation, but we have to obtain the differential equation, and for that we have to differentiate it again and remove the constants. Now on differentiating it second time, we will get this sin x ka cos x. And this will be same. Now from this equation we have to find out the value of this c1 plus c2 cos x plus c3 and put it in the equation third. So we will get minus y c4 e raised to power x plus c5 minus again this term, and these both term will add to give this. Okay. Still there are constants, so we have to differentiate it again. So on third differentiation we will get this term will be same. See here that we can find out the value of this term from this equation and we can put it in this equation. So from here the value of this term is d2y upon dx square plus y. Now put this value in the next equation. Now you can see here that there are no more constants in this equation. So this is going to be the final differential equation. And you can find out the order of this differential equation, and the order is 3. Okay. Now the second question is the solution of the differential equation dy by dx ka whole square minus x dy by dx plus y is equal to 0, and there are 4 options. First is y is equal to 2, second y is equal to 2x, third y is equal to 2x minus 4, and y is equal to 2x square minus 4, and the question is available on the screen. Now to find out the solution of this differential equation, we have to find out the answer using the options. So here the first option is y is equal to 2. Let this be the solution, and we have to differentiate it. So here we get dy by dx is equal to 0, and on putting this value in this equation, what you get, this is equal to 0 minus x into 0 plus y is equal to 0. So here y is equal to 0, but this is not satisfied. Here this y comes out to be 0, and here we have taken the option y is equal to 2. So the option is not correct. Now moving towards the second option, y is equal to 2x. So in this way you can find out your answer using the options also. So here dy by dx is equal to 2. Now again put this dy by dx into this equation. We will get 2 square minus x, here 2, so this will give 2x plus y. Okay, so here y is equal to 2x minus x square, but the option gives y is equal to 2x, so this will also not satisfy the equation. Now the third option is y is equal to 2x minus 4. Differentiate it. dy by dx is equal to 2. We obtained this equation. Now putting this value in the given equation, we will get 2 square is equal to 4 minus 2x plus y. So here y comes out to be 2x minus 4, and here y is equal to 2x minus 4. So this satisfies the equation. That is why option third is correct. You need not check the fourth option. Now the third question is on the screen. If yt is the solution of 1 plus t dy by dt minus ty is equal to 1, this is actually the differential equation in terms of t. I'm again repeating the question. If yt is the solution of the differential equation and y0 is equal to minus 1, then y1 is equal to. Okay, and for that you need to solve this equation and then find out the value of the constant, and then you can find out y1. Okay, so let us solve it. So on simplifying, we get dy by dt is equal to t upon So you can see here this is a form of linear differential equation, and for that we need to find out the integrating factor of this equation, and only then we can find out the solution of this differential equation. So linear differential equation is of the form dy by dx plus py is equal to q. Okay. So on comparing this, and I think I should tell the integrating factor, e raised to power integral p dx. Okay. Now for the integrating factor of this equation, here we have to compare and find out the value of p. So e raised to power okay, this is the integrating factor, and we have to find out the solution. And if you know the integration basics of integration, then you can find out the value of this, and the value comes out to be, the integration comes out to be okay. On separating these terms, we get and this is the basic thing that e raised to power log of anything will give you simple this. Okay. Now the solution of this differential equation is y into integrating factor is equal to integral of q into integrating factor into dt. Okay. So y into integrating factor e raised to power minus t 1 plus t is equal to integral of q is 1 upon 1 plus t and integrating factor is, where is that? Okay. So this term will be cancelled and you can easily find out the integration of e raised to power minus t. Okay. And you will get the final solution of the differential equation. So here this is okay. So this will give e raised to power minus e raised to power minus t plus c. So this is the equation with constant, but we have to remove the constant. So on putting t is equal to 0, here is y. So y becomes minus 1. Y becomes minus 1 and this becomes, you can put and find out the value and this will come out to be 1 and this will come out to be minus 1. So from here c comes out to be 0. Fine. You can put the value here and we will get the equation. So this is the equation. Now we can find out the value of y1. So on putting the value t is equal to 1, we will get the value of y. One plus 1, 2. So remove this. This will be cancelled and y will be equal to 1 upon 2. This is the answer. Now the fourth question is on the screen. If y is equal to yx and the given differential equation 2 plus sin x upon y plus 1 dy by dx is equal to minus cos x and y0 is equal to 1, then y pi by 2 equals. So this is the similar question that we have discussed, and to find out the answer we have to first solve the equation and find out the constant using this given value. So first simplify this. We will get, okay, so you can easily separate the x terms and y terms. Okay, this is the obtained equation and we have to integrate on the both side of the equation. So this will give log 1 plus y and you can easily integrate. You can take the term t and this is an easy integration. You can solve it like this. You can take 2 plus sin x is equal to t and this will give, on differentiating, this will give. Okay, So replace this value by dt. So this will give minus dt upon t. Minus log t. So this is the equation. You can remove the log very easily. Now this is the equation. Now I'm not going to solve the whole question. You can easily solve it using this equation. First find out the value of constant using this equation and then find out the value of y pi by 2. Okay. Now the next question, if x dy is equal to y dx plus y dy and y1 is equal to 1, then find out the value of y is equal to minus 3. So let us solve it. Now you can easily get the idea that this is actually the differentiation of x upon y. So you can write it as this, and on integrating we will get x upon y is equal to x plus c. So this is the solution of the differential equation, and you can find out the value of the constant using this equation y1 is equal to 1 in a similar way, and you have to find out the value of y is equal to minus 3. Then you can find out it easily, okay, after finding out the value of constant. So in this way you have to solve the fifth question. Now moving towards the sixth question. Now the sixth question, the differential equation dy by dx is equal to under root 1 minus y square upon y determines a family of circles with, and this question is available on the screen and you have to observe the options also. So according to options we have to find out the solution and then find out from which family this equation belongs. Okay. So let us solve. Now using the substitution method we can integrate this equation. Now replace t by y. So we will get squaring both sides. And this is the obtained equation, and you can see that this is the equation of circle, and we have to find out which option is correct, and for that we have to find out the radius and the center of the circle. And from here the center of the circle comes out to be C, 0, and this is the center, and radius comes out to be C square plus 0 square minus the constant, that is the radius is 1. So our third option, that is the radius is 1 and the center may lie on the x-axis. This is arbitrary because we don't know the value of C. So we have done all the 6 questions which are very important from this chapter, differential equation, and I will come very soon with next 6 questions from other chapter also. So stay tuned. Goodbye.